All right, boys and girls, I'm going to be talking to you guys today about how you can use your understanding of half to help you compare fractions with models, and eventually without models. So third grade, you'll always have a model, and in fourth grade, you'll be expected to use your reasoning without models. So the first step is you need to have a really good understanding of half. And to explore that, I have two models here, including fraction bars and a ratio table along the bottom. First thing I'm going to do is I'm going to drag this up to the top, and I'm going to show 1/2 of the whole. So the top bar represents one whole, and then the second bar is split into two equal parts. So I dragged it to shade over one of them to show that that's 1/2. And you can see down here on my ratio table, that black fraction is the ratio or fraction 1/2. The next thing I'm going to do is I'm going to jump down to my fourths. I know these are fourths because there's four parts that make a whole, but instead of highlighting all 4/4, I'm only going to highlight as many fourths as I need to equal 1/2. And how many fourths was that? I can see that it was 2/4. You could keep going down like this. All of the black fractions, or the fractions with the easier denominators, they're easier because they're even. I'm going to take you into fourth grade a little bit. Even if you're in third grade right now, you might understand this. Wonder what would be half with thirds. Let's just explore that for a second. I'm going to go to this bar here that's split into three equal parts because I know three equal parts that make a whole would be thirds. This would be 1/3. I can see 1/3 is less than a half. If I had 2/3, I can see that 2/3 would be greater than a half. That doesn't mean that there's not an equivalent for half with thirds, but what it does mean is that you would have 1/3 and then half of another third. So that would be like 1 1/2 thirds. So in fourth grade, you'll learn how to write decimals like this for 1 1/2 thirds. Anyway, as you have fun exploring all these ways that you can make half with fractions, then you're ready to actually use the strategy of using a benchmark of half to compare fractions. I'm just going to jump down to this model. It is a number line model. I have mixed in area models and number line models in here, so y'all get practice with both. Let's take a look at this one. So 3/8. I'm going to model 3/8 by finding the number line that is divided or split into 8 equal parts, which would, I believe, be this one. Let me just double check. That'll be 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Okay, but I only need 3 of them. Now, sometimes you might have this rectangle shading over the line. Sometimes you might have an X or a dot right here on the point where 3/8 would end. The second fraction I'm going to be looking at is 6/10. I'm going to use my red and I'm going to find my tenths. And I'm just going to highlight up to 6 of them, 6/10. That would be the same as 6/110. I know that 4 would be left. All right, so now I'm going to use that reasoning about half. Remember with eighths, what would half be? Half would be 4/8 because 4 is half of 8, right? What would be half with tenths? Half with tenths would be 5/10 because 5 is half of 10. So if these are my half equivalents up top, now I can use my G and my L, which stands for greater and less, to reason about which of these fractions is greater. If 4/8 equals a half, then 3/8 must be less than a half. I'm going to drag over my L. If 5/10 is a half, then 6/10 must be greater than a half. So now I can read my comparison here. 3/8 is less than 6/10. So let me go ahead and drag what I need to actually say that. 3/8 is less than 6/10. And finally, I'll drag in my inequality symbol with the larger opening facing the greater fraction. And there you have it. That's how you use a benchmark of half to compare fractions. When you have one fraction that's less than half and one fraction that's over half, then you can think about what that half is to figure out which fraction